Right, back again. So we've just done all about the anatomy of a wave, where we've learned that the top point of a wave is the crest and the peak, and the bottom part of a wave is called a trough. Now what we're going to learn to do about now is the properties of waves. Properties of waves means how the wave changes, and how we can use that to interpret the speed of the wave or the height of the wave. So basically what you need to know is waves change. They don't all look like that. Some of them become higher and lower, others are very more compact. Okay, so that is a property of a wave, what it looks like. We can calculate properties of waves, and we're going to label them. So, amplitude. What you need to know is amplitude. Amplitude is the height of a wave. Okay, so from the rest position, it's the distance from there to there, to the top of the wave, or it can actually be the bottom. Okay, usually it's the same. So from the rest position to the bottom point of a wave. Okay, and usually on your left-hand side here on your chart, you'll have numbers. Okay, and these will represent the height of the wave. So it'll be in meters. So here, if we go 1, 2, 3, 4, all the way along, the amplitude of the wave, which is the height of the wave, is 4 meters. Okay, and that's what it means, amplitude, height of the wave. The amplitude will change depending on the medium. Okay, so remember that word, medium was the substance that it was traveling through. So, for example, I have some sound, right? The sound wave would travel faster through a solid subject material. So it would have a higher amplitude. And then it would be slower for air because it's being dispersed. And then that would mean the amplitude would be low. So, for a wave going through air, it would be low. If I went and put the sound wave through on a solid surface, it would have higher curves. Okay, so that's what that represents. Height represents the type of material a wave is traveling through. Okay. Wavelength. Wavelength, super easy. It's the length of a wave. So, one point here, the top of a wave. How long is the wave? It takes from one full wave. So until you get starting to get repetition. So when it becomes back to the same thing and you're repeating itself again. So one full wave is one part of a repetition, okay? And that is what it is. It's represented by the symbol lambda. And it is measured in meters, okay? So wavelength, I've drawn you one wavelength here. It's from there to there, okay? It doesn't have to necessarily be from the peak to the peak. It could start halfway along here. So for example, we start here on the rest position. If I wanted to find the wavelength, it would be from one there. Okay? So that's your wavelength. Frequency. Okay, frequency is how we count the number of waves that pass a certain point in a certain time. Okay, so that's represented by hertz, the symbol's Hz. Now have a look at the diagram again. So imagine, right, from here to here is 1 second. What you do, you know you've 1 second's gone past, count your waves. So if you start here at your bottom point, you've got 1 wave. Your second point, 2 waves. So you know that this wave, there's 2 waves have gone past in 1 second. So have a quick look, frequency, 2 waves in 1 second, means it's 2 hertz. Okay? 2 hertz. So 2 waves per second. If we change it up, what happens if it was 10 waves in 2 seconds? So how many waves per second? 10 divided by 2 is 5 hertz. So, if a wave's going past in 2 seconds and 10 waves go past in 2 seconds, it gives you a frequency of 5 hertz. Okay? So, frequency, number of waves to pass a point in a certain time. Speed. Speed is easy. It's how fast the wave travels in that time. Okay? So, how many waves go past, frequency, how fast it goes in that time is speed. Bananas!